Okay. So, good evening, everyone. Today, in the morning session, we have instrumentation paper, and we will discuss a few, questions that have been asked in this today's exam. From the overall, paper perspective, I believe that this is one of the easiest instrumentation papers that we have got in the last 5 years. I believe.
Correct.
From across all subjects, the questions were quite easy. Okay, there is no subject that we found where the questions are even kind of moderate to tough. Also, I think all questions
Very
are very. I think there is only one question that we have seen in analog, which is kind of okay, decently good question. The op amp having cascade of 3 op amps. But yeah, rest all I think can be solved in 1 to 2 minutes of time. I don't think it'll take more than that.
Even signals control maths is pretty straightforward.
Yeah.
Okay. So guys, next week EC and EE exam is there. So our intent is to, discuss some questions so that it is just like a practice also. And those who have written, many of you might have written today's IN paper. So you can also check your questions. These all questions are memory based. So if there is any connection, you can let us know in the chat box immediately if this data is here and there. It is all memory based, but the intent of the question will be clear. Okay. So network, analog, digital, EMF, signals, control, maths, few aptitude questions, and as well as machines and measurement questions. So Rinder sir will also join shortly. So W students can also be watching into that.
Yeah.
Okay. So yeah, guys, let's start the questions and we'll keep talking as and when required.
Okay,
sir.
Okay, so first we'll start with digital. Again, a very easy question. This is generally a state level exam question. The number of comparators in a 6-bit flash type ADC, and the number of comparators usually in a flash type ADC, the number is basically always 2 power n minus 1. That's it. So here n is given as 6. So hence this is equal to 2 power 6 minus 1. The answer is 63. Okay. So quite a simple question this is. Okay. So let's go for the next question. Again, number of 8-bit, there is an 8-bit comparator comparing two 8-bit numbers, A and B. And in how many cases we'll have A becoming equal to B? See here in class, I'll generally give, 3 formulae total. One is 2 power 2n. One is 2 power n. And the third one is difference of both by 2. So which is 2 power 2n minus 2 power n by 2. This is the total number of comparisons. Total number of comparisons. This is for the case where we have A equal to B comparisons. And this is for A less than B comparisons as well as A greater than B comparisons. Okay. So in this case, the question is all about number of A equal to B comparisons. In how many cases we'll have A being equal to B? The answer is what? 2 power n. That's it. Okay. So the answer is now 2 power. What is n? The size of the comparator. This is a 8-bit comparator. So this is 2 power 8. Answer is 256. That's it. Okay. So if you simply attend the lectures, I think this is a pretty much straightforward question. We don't even have to construct the circuit here. It's all about number of comparisons. Okay. So this is again a straightforward formula based question in a some ADC, 16-bit ADC, what is the value of SNR, maximum SNR? So the SNR in case of ADC has a certain formula, that is 1.78 or 1.8, approximately people take it as 1.8 plus 6.02 n, which is approximately 6n, where n is the number of bits in the ADC. Okay, so this becomes equal to, n is equal to 16. Okay, so you can take it also as nothing but 1.8 just for easing of calculations. 16 6 are how much? I think this is 96 plus 1.78, which is equal to 97.78. And by the way, this is the answer in terms of decibels. This is the answer in terms of decibels. So roughly you can say this is 97.8 decibels. Or roughly 98 decibels if it is integer. Okay, the closest integer, right? Yeah, good. Next, this is one question again straightforward from handouts. You can see So we have a synchronous counter, common clock for all the flip-flops. We have been given some initial state 1 0 1 1. Then the state after 2 clock pulses is dash. Okay. So what is the present state here? Luckily, if you see, this is a shift register counter wherein the output of the first flip-flop is given as input to the second, input to second is given as input to third, the output of second is given as input to third, the output of third is given as input to fourth. So whatever bits we have, the first 3 bits are shifted towards right side. Please note, the first 3 bits are shifted towards right side. And what is the input to the last bit? The input to the leftmost flip-flop is what? It is the XOR of the last 2 bits, which is Q1, Q0. So, we'll construct the table. Present state, we don't even have to construct the table if you know the logic, but nevertheless, we'll do it. Then present input, and then after giving a clock, next state. Okay, what is the present state? Q3, Q2, Q1, Q0. And what is the present input? D3. Yeah, D3 is equal to XOR of Q1, Q0. So Q1 XOR Q0. D2, D1, D0. All these are basically shifted version of the previous state, which is D2 is equal to Q3, D1 is equal to Q2, D0 is equal to Q1. So this is Q3, Q2, Q1. Given this, you are supposed to find out the next state, Q3, Q2, Q1, Q0. Okay. Okay, the initial state is given 1 0 1 1. Okay, like I've told, the first 3 bits are shifted towards right side. The first 3 bits are 1 0 1. So 1 here, 0 here, 1 here. Then what about D3? It is XOR of Q1, Q0. XOR of 1 1 is basically 0. Okay. So this is your next state, which is 0 1 0 1 0 1 0 1. This is after first clock. This is after first clock. Okay. So we take 0 1 0 1 as the present state now. First 3 bits are 0 1 0 shifted towards right side. 0 1 0. XOR of 0 1 becomes equal to 1. Okay. So 1 0 1 0 becomes equal to the next state. So this is basically after the second clock. That's it. Okay. So we have to construct the table, and ultimately it's all about just 2 rows. So after 2 clock pulses, what is the state right now? It becomes equal to 1 0 1 0. Okay. Yeah. So this is all about this question now. Okay. So next. Yeah, I think next we have questions on yeah, I think there is one more digital question. I'll just write the question. It's a question on computer organization. It's a very, very basic question. So we have basically a computer which has the instruction size of. It is a very, very simple question. A similar kind of a question has been asked in GATE 2023, if I'm not wrong, or 24, either 23 or 24, but very simple, very similar question, very simple question, both of them. The instruction size is given as 16-bit. Okay. And then the opcode size, every instruction will have few entities. One is, space for opcode, and that is basically 7 bits. Okay. And we are using either memory location, that is memory, the size for memory, port, which is 3 bits. Again, please note, this is the size for memory port. Okay. And then we have 2 registers. Either we are using 2 registers or we are using 1 register and this memory port. Okay. And what is the size of this register address? So for register address, we are using again 3 bits each. And finally, immediate data. Immediate data. So immediate data again uses 3 bits. Okay. So given this, you have 4 options. It's an MSQ question. The options are how many instructions we can have. So total number of instructions first. It is given as 512 in one option, and total number of instructions is equal to 256 in one more option. Okay, no, I think 512 and 128. And then total number of registers. Total number of registers is given as, I believe, 8 as well as 16. Okay, so these are the options that you're having. See, we have the instruction size to be total 16 bits. So you can think of it like this. Okay, this is basically some random instruction. Okay, so in this instruction, we can have basically 3 or 4 boxes you can think of. One box has opcode inside it, and then we have a couple of boxes which have space for basically register or immediate address. Total 16 bits we are supposed to use. So this is first of all for opcode. Okay, and then opcode uses how many bits? This is for 3 bits. And then we have 3 boxes each of 3 bits. This is a 3 bit, this is a 3 bit, and this is also a 3 bit. Okay, so what are these boxes for? These boxes are for either registers or memory or immediate data or combination of any one of these things. Okay, so here what we are using? We are using the remaining part, that is basically, well, you know, one combination could be, here we are using register 1, here we are using register 2, and maybe here we are having immediate data. Okay, or one more way of, you know, showing the same instruction could be, this could be one register and this could be one memory port. Okay, memory port address, and then we have immediate data, something of that sort. So either we are having both registers or one register and one memory port, something of that sort. Okay, this is the basic, you know, way in which the memory is being present, or the instruction is being present. Now, given this data, let's look at the options. First option talks about the number of instructions. The number of instructions depends on the number of opcode bits. We are having 7 opcode bits, means how many combination of those 7 bits we can have? We can have 2 power 7, which is 128 instructions. So the number of instructions here, okay, so the number of instructions is equal to 2 power number of opcode bits. And how many opcode bits we are having? We are having, 7 opcode bits. So 2 power 7, 128. That's it. Next is number of registers. How many registers we are having? It's equal to, again, 2 power number of register bits. So how many register bits we have? So 3. We have, for each register we are having 3 bits. Yeah, we are having 2 register address locations. So this, code, if it is 000, let's assume, it corresponds to one register, and if it is 001, it corresponds to another register. So we are having spaces for 2 registers, but for each register location, how many bits you are having? 3 bits. Okay, so it is equal to 2 power 3. The answer is what now? 8. Okay, so that's it. So the answer is what now? I think 128 number of instructions, and total number of registers is how much? This is 3. Sorry, 8, 2 power 3, which is nothing but 8. That's it. The correct answer is number of registers is 8, number of instructions is 128. Okay. Yeah, this is regarding digital. So if you see, all questions are quite simple, nothing complicated whatsoever. Okay. Yeah, next we have signals. Rakesh sir will take signals. Okay.
Okay, guys. So signals, to be honest, has been very easy. If you see last year IN paper, signals was relatively better. Okay. So yeah, let's look into the signals question. What is their convolution question coming up directly? Okay, convolution of xt and yt. This is only one question where little bit effort is required, and that too easy effort only. But rest I will show you how easy it is. Okay, so if yt is given to you, let's say zt is xt convolution yt. Okay, number one, you can solve by convolution formula also, or if I just convert to the S domain, what is going to be Zs? Okay, xt is ut minus 2 minus ut minus 3. Tell me the Laplace transform for ut 1 by s, then e power minus 2s time shifting. For ut minus 3, again 1 by s, e power minus of 3s. This much it is. Yt, what is the Laplace transform for e power minus 4t ut 1 upon s plus 4? Okay, so overall, it is e power minus 2s minus e power minus 3s is divided by s plus 4. Okay, let the exponential term be separated. I'll just do the partial fraction on 1 upon s plus 4. How much it is going to be? It should be represented by a simple subtraction, and when I subtract, 4 will be there. So I'll write down this 4 here. Okay, no need to apply any partial fraction method, is already obtained. Okay, now what is going to be the inverse Laplace transform of this? Okay, if I have to come to ZD, you see here, if you only talk about this much part, this corresponds to how much? Ut minus e power minus 4t ut minus e power minus 40 ut. Okay, then the total answer should be how much? 1 by 4. This is the constant. Then e power minus 2s. Okay, e power minus 2s, of course, again represents time shifting by 2 in the time domain. Ut minus 2 minus e raised to the power minus 4 t minus 2 u of t minus 2. Options are not there. Okay, whether they ask convolution at a specific point or whatever it is. Okay, this is one part of the answer. Minus for this one. Okay, no. Then for with e power minus 3s, if you solve with e power minus 3s, so time shifting by 3, u of t minus 3 minus e raised to the power minus 4 t minus 3 u of t minus 3. Something like that answer has to be there. Okay, something like that answer has to be there. Okay, yeah. Okay, otherwise, if you want, you can also go for this approach. Okay, e power minus 4t ut. Okay, this is, another way of dealing this. Okay, by using one of the standard result, e power minus 4t ut, convolution only with ut. Okay, convolution only with ut. Why? Because, okay, if you remember, one of the standard case, e power minus 80 ut convolution with e power minus bt ut. Okay, is given by what formula? E power minus 80 minus e power minus bt divided by b minus a. Okay, into ut. Okay, when both are exponential signals, right-sided exponential signal, we can directly use up this one. So if you want, you can use this e power minus 40 minus e power minus bt, which is 1 upon what? Upon b minus a. So b is 0 for me. B is 0 for me, a equal to 4 for me. Okay, so if I put b minus a, it becomes minus 4. Okay, then you can reverse the numerator. Okay, this is also one way of solving. Then you apply time shifting here. One is with ut minus 2, one is with ut minus 3. Both are okay method. Whatever you want, you can solve accordingly. Okay, both are okay. Anyways, we have got the answer. If there is any correction in the question, guys, because all this is memory based. Okay, so if you think that there is any correction in the question data, acha, answer is in S domain only, Vishnu Reddy. Okay. Oh my God. So then I was thinking this is the only one question of signal where little bit effort is required. If the answer is in S domain, what is there? Finished. What is there? Then it becomes very much easy. At least one question I thought some calculations are required. That too easy calculation. But if you are telling it is in S domain, then no problem. Okay, then the question is more simple. So that means today's paper, they thought they have to make it very easy only. No complication, no calculation also. Very direct question, guys. If you have our class notes, linearity and time invariance of the following system. Okay, x square, clearly non-linear function. First, I'll comment on linearity. Whenever x power 1 function, it is all linear. Okay, time scaling, time shifting does not affect the linearity. If y depends on x power 1, input-output relation has to be a straight line passing through origin. That's it, simple. So the rest 3 are linear, first one is non-linear. What else is there? Time invariance. Okay, now what are the factors which are going to make the system time variant? Okay, time scaling, time shifting, any type of change in time argument or any separate function of time. So from time invariance point of view, what is this? Okay, there is no separate function of time, there is no change in time argument. This one is time invariant. Okay, x of minus t, changing time argument, that is time folding. This will make the system time variant. Again, minus t will make the system time variant. Okay, this is only t. Okay, time shifting does not affect the time invariance. Okay, options are not available. Okay, maybe it was a MSQ question, or maybe they asked which of the system is LTI. Okay, especially they asked LTI, so then this becomes the last one, which is linear and time invariant both. So that options are not there that you can decide. Okay, just keep us updated at whether question is correct or not, because all memory based. Any additional data, please do mention honestly. Okay, then what is there? Okay, again on classification. See, 2 questions only on classification. Okay, what is there? Which of the following is not representing a linear dynamic system? Okay, not representing a linear dynamic system. Okay, I think the question what I got from one of the student is not linear but dynamic. Okay, not linear, but anyways, since differential equation is involved, yeah, it has to be not linear. I mean, non-linear and dynamic, because differential equation coming, so it is dynamic at the any cost. Okay, because all are derivative terms, the dynamic is there for sure. All of them are dynamic. All of them are dynamic. Now, if you see, the first one, what is there? Input, input is ut, output is xt here. Xt, x dash t, x double dash t. All of them are in first derivative. Sorry, in first power. Okay, the signal, the first derivative, second derivative, all of them power 1. So this has to be linear. Okay, if you ask about time invariance, question is not asking, but again, a product of time, separate function of time, it will be time variant. Now you see second derivative power 2. Okay, power 2 clearly makes the whole equation non-linear. Now here again, xt power 1, first derivative power 1, second derivative power 1, input also power 1. Okay, all input output terms are in first power, this one is linear. So if you wanted non-linear and dynamic, okay, so then it is clearly option number A, 2 only. Okay, option number A. I think this one, 1, 2, I think one more question was there or what? Acha, this one. There's one more question. Okay, very direct. What is the fundamental period of this? Okay, so what is going to be the fundamental period? Okay, you just tell me what is the fundamental. See, both the signals contain pi. So when you take the ratio of time periods or when you take the ratio of frequency, it is going to be rational or not? When will the problem come? Okay, the problem will come. Okay, one of the signal contained pi, one does not contain pi, because the sum of two periodic signals is periodic if the ratio of time periods or ratio of frequency, anything you check, has to be rational. Ratio of integers, and pi is irrational. But luckily both have pi, so when you take the ratio, the integers part will be left. It is rational number. This is number 1 point. What else is there? Then what is the final frequency you can decide here? Final frequency is always given by HCF of omega 1, omega 2. So when I'm going to take the HCF, what it is? 15 pi, and how much it is? 4 pi. Okay, so only pi, if you take outside 15 and 4, what is the HCF? It has to be 1 only, na? What can be the highest common factor? It is only 1. Okay, so the net frequency is pi. So net time period, 2 pi by omega, that is going to be 2 pi upon pi, and that is equal to 2. Or you can find individual time period and then take the LCM of time periods, or the ratio cross product, whatever method you remember from our class. Okay, time period is going to be 2 ultimately. Okay, right? Acha, Vishnu Reddy says that this particular question was, yeah, that is also probable. This question matched the following. Okay, similar questions have been there in previous year. Okay, they'll give the match the following. Okay, that is okay, right? Okay, Deepak, for cutoff, you have to wait. Let's get more questions. Okay, we have got many questions today, but not all 65. So without looking into all 65, it's not correct to comment on the cutoff right now. But paper, whatever, see, 40, 45 questions we have got. Okay, the paper is very easy. Okay. Okay, I think Vishnu is mentioning some more counter question. Okay, we'll see. Okay, so I'll now ask Gautam sir to join again. Network question. I'll again come back for maths and controls. Again, easy only. Again, easy only. I'll call up Gautam sir. Sir, Gautam sir. Okay. Yeah, guys, Surendra sir is coming to discuss 2 questions of machine. One question is here. I think this one.
Right. Very good evening, everybody. So I hope you attempted the exam well. Yes, we have a few questions from electrical machines subject. It was a simple question. I don't know exactly whether it is 1 mark or 2 marks. I am expecting it is going to be a 2 marks for an instrumentation level. So a single phase transformer, 10 kVA, 50 Hz, 110 by 220 volt, OC test conducted on LV side with HV side open circuited. See, OC test details are given. Based on the OC test details, we asked to calculate what is the magnetizing reactance, right? See, as it was open circuit condition, we know during open circuit condition, the equivalent circuit of the transformer will have only shunt branch parameters, right? So this is open circuit voltage, and this is I0, no load current or open circuit current. This is a core loss resistance, and this is a magnetizing reactance. Okay. magnetizing current and loss component current. So this is exactly the equivalent circuit of transformer during open circuit condition. Now we are asked to find out this reactance. See, as it is a shunt branch, can I say this reactance is simply the ratio between voltage and magnetizing current. In this, the voltage was already given. What is the voltage value? 220 volt, correct? Yes. Therefore, to find out this reactance value, we just need what is the magnetizing current, right? So, according to the information, the no load current was also given 2.75 ampere. This current was already known. Therefore, to find out this magnetizing current, I need this loss component current IW. How can we find loss component current? Yes, we can easily find out using iron loss information. Yes or not? Yes. So during open circuit test, we know the entire active power drawn by the transformer is equal to iron loss, right? So what is the magnitude of iron loss? 363 watts. Okay. Iron loss is equal to 363 watts. And what is iron loss formula? It is simply VOC into IW. This is equal to 363 watts. From this, first we can find out IW value, that is the loss component current. 363 divided by voltage 220. Okay, you can use calculator and you will get IW value. Let me use calculator. So 363 divided by 220. So 1.65 ampere. Okay, the moment I got IW, I can easily find out I mu also. Yes. So what is I mu? We know I mu is equal to square root of I naught square minus IW square. Right. So this is 220 divided by what is the no load current? I naught. I naught is already 2.75. So 2.75 square minus 1.65 square. So if you complete it, you will get the magnitude of magnetizing reactance. But remember, the test is conducted from low voltage side. Therefore, whatever the reactance we got here, that is the reactance referred to LV side. What is the question they are asking? They just said, what is the magnetizing reactance referred to primary, they said. What is primary? Primary is already low voltage. Therefore, whatever the answer you got from this calculation, that will be the final answer. Sometimes in exams, they may also ask you, what is the reactance referred to secondary side? Secondary will be HV. Then what you need to do? You have to transfer this reactance to HV side. Got it? So let me complete the calculation. You'll get the final answer. 2.75 square minus 1.65 square. Okay, I'm getting 0.01 ohm. Okay, let me verify this again. 2.75 square minus 1.65 square. Not 0.0. Sorry, 100. 100 is the correct answer. Yes. 100 ohm is the magnetizing reactance. That is the final answer. Okay. Yes. And before going to next question is not in the PPT, but I have the information of that question. Okay, let me write down. Any empty page? Okay. Yes. So let me discuss that question. It was a simple question again from transformers only. A transformer was given, okay, like this, and primary side is HV, secondary side is LV, and there was a load impedance given on the secondary side ZL, and the load impedance seen from the primary side is ZL dash. They just asked us, is ZL dash more or ZL is more? For example, the load impedance is on the secondary side, right? If this ZL was transferred to primary side, it will become ZL dash. So how to transfer impedance from secondary to primary? So simply ZL dash will be equal to, we are transferring to primary is HV. Therefore, it is HV by LV whole square times of ZL. Correct? Because we are transferring to primary is HV. And HV by LV, is it not greater than 1? Definitely, because HV will have more turns, LV will have less turns. So more turns divided by less turns. So this square product will be greater than 1. Therefore, ZL dash is greater than ZL. They gave 4 options like ZL dash greater than ZL, ZL dash less than ZL, ZL dash equal to ZL. Probably this will be a 1-mark question and a very simple model. That's all. These are the 2 questions we got from electrical machines subject in this instrumentation paper. I would say they are dead easy questions. Okay, especially if a student is from electrical background, they can solve it just like that. But if a student is from instrumentation background, they may find these questions as average questions, not so difficult, not so easy. Okay, right. Thank you so much. So now Gautam sir will continue.
Alright guys, let's continue. Now we'll look at the questions from network theory. So I hope you can see the question. So this is the first question. Yeah. So this box over here is what a 2-port network for which the Z parameters are given. And these are the Z parameters. And across the output port, a load resistance is connected, and across the input port, a voltage source is connected with an internal resistance of 5 ohms. And the question is what the value of RL for which the maximum power will be delivered to the load is how much. Okay, so it's just a pure application of maximum power transfer theorem. So you know very well, when you choose RL to be equal to what RTH, then only maximum power will be transferred to RL. So it's all about finding RTH. So what is that RTH? I just want to clear this off. So with respect to RL, the entire remaining network, with respect to RL, the entire remaining network, it is what? A single port network. Yes or no? With respect to RL, remaining network can be thought of as what? A 1-port network. And when this load resistance looks into this single port network, whatever equivalent resistance it is going to see, that is what we call the Thevenin resistance, RTH. And your RL, you should choose it to be equal to what? RTH. Then only maximum power will be delivered to the load. So this is the essence of maximum power transfer theorem. First of all, if you observe Z12 is equal to Z21, which is what the condition for reciprocity. Okay, one thing that we can do is what? You can call this voltage across port 1 as what? V1. You can call the voltage across port 2 as V2. And the current at port 1, you can call it I1. And the current at port 2, you can call it I2. And then you can replace RL with a test voltage source VT, and you can try to find VT by T. Of course, this 5 volt source, you have to make it 0. This 5 ohm internal resistance will remain. And then VT divided by IT will be nothing but the Thevenin resistance. That is one thing you can do. But if you make this small observation where Z11 and Z22 both are equal, which implies the 2-port network has got symmetry. And also the fact that Z12 and Z21 are equal it indicates that it obeys what? Reciprocity. And in general, resistive networks will obey what? Reciprocity. Okay, so we can easily model this two-port network. I mean, we can easily represent this two-port network for which the Z parameters are given with a simple resistive network. Okay, so I'll just draw a T-shaped network. So this is how you can model or represent the given two-port network with a resistive network. Okay, so is port 1 and that is port 2. So if you call this resistance as RA, and if you call this one as RB, and if you call this one as RC, so for this two-port network, the Z parameters can be easily written as what? RA plus RC, 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 and then RB plus RC. So this is how we can directly write. I mean, not directly, but if you are already familiar with this, you can easily write this. Okay. So once you write this Z parameter matrix in terms of the three resistances, now you should compare this matrix with the given Z parameters, which are what? 10, 5, 5, and again 10. So it is quite obvious that RC is what? 5. So what is RC? It is 5. And then RA plus RC is what? 10. Given that RC is already 5, even RA is also what? 5. Even RB plus RC is what? 10. Again, RC is 5, so RB is also 5. The point is, each and every resistance has the same value of 5 ohms. Okay. So what is this? 5 ohms is also 5 ohms and is also 5 ohms. And then across the input port, again a 5 ohm resistance is connected. And then you have to find the Thevenin resistance seen from this side, which is nothing but the equivalent resistance, right? So 5 and 5 in series is 10, 10 in parallel with 5. And again, that combination, it is in series with 5. Okay. So what is your RTH going to be? 10 parallel 5 is what? I think 10 by 3, correct? 10 into 5, 50 by 15. 10 by 3 and then plus 5, which is 25 by 3, which is some 8.33 ohms like that. Okay, so if you choose your load resistance to be equal to what? This much, like 8.33 ohms, then you will have maximum power getting delivered to the load. Moving on to the next question, what is it? Again, some simple network is given. You have been asked to find V out, which is the potential difference between this point and this point. If you want, we can call this as A and this one as B. Okay. And in this network, two sources are there. Both are identical voltage sources, each of value 4 volts. I mean, you can do it in many ways. First of all, this 2 and 2 both are in parallel, which becomes 1 ohm. That 1 ohm and this 1 ohm both are in series. Yeah. And I think for this one, you can do source transformation. For this 4 volts in series with 2 ohms, you can do source transformation. Okay. So this entire thing can be replaced with a single resistance of value 2 ohms. Okay. And then 4 volts in series with 2 ohms can be, so first this 2 ohm resistor I'll draw. Okay, 2 ohms. When you do source transformation for this branch, it becomes what? Resistance in parallel with the current source. 4 by 2 is 2, so 2 amps, and this again is 2 ohms. And then you have the remaining network. Okay, it's not the complete network, but again you can do a bit of simplification here. Okay, so 2 and 2 both are in parallel, which is 1 in parallel with 2 amps can again be transformed into 2-volt source. Yes, 2-volt source in series with what? 1 ohm. Yes. And now I'll draw the remaining circuit. In fact, this 1 ohm will be in series with this branch. Okay. So when you combine 1 ohm with this 1 ohm, I think this you can change it to 2 ohms. And then I'm going to draw this branch. Okay. Which is 2 ohms. And then 4 volts. That's all. Now it is what a single loop, for which you can easily find the loop current. Just change the color. So the loop current will definitely flow in this direction. And the value of this loop current will be what? 4 minus 2. So if you call this loop current as some I can be directly written 4 minus 2. Yes, 4 minus 2 upon 2 plus 2 by 4 is 0.5 amps. Okay. So through this 2 ohm resistor, 0.5 amps will flow in the upward direction, due to which a voltage drop of 1 volt will appear across this 2 ohms. And the question is what to find the potential difference between this point and this point. Okay. So between this point, okay, again, this is A, this is B. So between A and B, we have 2 voltage drops, and then you have to subtract because plus is connected to plus. 4 minus 1 is 3. So what is the value of V out? It is 3 volts. Okay. And this is, I don't know what to call this, but it's a question. Okay. Let's move on to the next question. Again, a simple RL circuit is given. The value of R is some 100 pi ohms and the inductance is 2 Henry. In the above circuit, I lags V, that is obvious, by 45 degrees. Okay. I lags V. I think they are implying Vs. The source voltage is Vs. I guess this is Vs. Okay. So I lags Vs by 45 degrees. What is the frequency of the current? Okay. They're just asking what is the frequency. So if you think of this circuit in the phasor domain, this becomes what? J2 omega. Yes. And then I will be the source voltage or the applied voltage divided by net impedance in this branch, which is R plus J omega L. So R is already there, 100 pi. And then the impedance of the inductor is what? J2 omega. Yes. And then if you compute angles on both the sides, yes, the angle of I is equal to angle of Vs minus angle of, what is the angle of this denominator? Tan inverse, okay, I'll just write the angle directly. Okay. So this angle of denominator will be tan inverse 2 omega by 100 pi. Okay. Tan inverse 2 omega divided by 100 pi. What is given in the equation? I lags Vs, okay, by 45. That means Vs leads I by 45, which means angle of Vs minus angle of I is what? 45 degrees. So angle of Vs minus angle of I. So let us send this angle I to the other side. Then you'll have angle of Vs minus angle I, which is 45 degrees, is equal to, and this minus tan inverse thing will bring it to this side, then it will become plus tan inverse 2 omega by 100 pi. Okay. And then if you take tan on both the sides, tan 45 degrees is what? 1, which means imaginary part and real part both have to be equal. That means 2 omega is equal to 100 pi. Yes. Now in place of omega, we can write 2 pi f. 2 times 2 pi f is equal to 100 pi. Okay, so pi will definitely get cancelled. F is 100 by 4, which is 25 hertz. In fact, your answer must be in units of hertz. The answer is what? 25 hertz. Okay. Let's move on to the next question. Okay, this is a simple question on electrostatics. So what I'll do, I'll try to find some questions from analog circuits. Okay. If there are any comments, I'll try to respond. Filter based circuit is given, answer is band stop filter. Okay. Also, I mean, you can do in any number of ways. You should just get the right answer. I think there is what a question on. I'm just continuing analog. So this is what a question on analog circuits. What is the value of V out? And this is what a standard circuit, okay, which everybody knows. Tips for electrical engineering based on this paper. This paper has nothing to do with electrical. So those of you who appeared in today's exam, you should only treat it as a warm-up. Okay, so IN has got no correlation with both EC and EE. Okay, so this paper I believe is very easy. Don't expect such an easy paper for electrical or EC. Okay, if it turns out to be easy, fine. But don't be under the impression that because IN is easy, EC will also be easy. Yes, electrical also will be easy. That is not going to happen. Okay, you should be ready for any type of paper. And most likely you should expect a good paper or a good question paper. Okay. If all questions are easy, then what is the point in having the exam? Okay. Anyway, what is the value of V out? So your V out has to be in terms of V in. Okay, V in. Oh, I'm sorry. Is it? What is the value of V out? V in is given. It is 100, and this is a standard circuit, right? So if you assume this voltage to be some V1, if you assume this to be some V2, whatever V1 is given, that is actually V1 minus V2. Yes. And because of the two op amps being in negative feedback, there will be what? Virtual short. Because of that, this V1 will directly appear at this point, and this V2 will also appear directly at this point. So this R, what is the drop across R? V1 minus V2, which is Vn. Okay. And you know, for ideal op amp, the two input currents are 0. And because this current is 0, these two currents are equal because this current is 0, this current and this current are equal. In other words, RF, RF, all three are in series between this point and this point. Again, if you want, you can call this point as A, this point as B. Whatever V out, you have to find this potential difference between A and B. Yes, and so if I ask you what is the current flowing from A to B, then it is the potential difference between A and B, which is V out divided by the net resistance between A and B, which is RF plus R plus RF. Okay. So V out divided by RF plus R plus RF, which is 2RF plus R. And that current can also be written in terms of the voltage across this middle resistor R. What is the current through this R in the downward direction? V1 minus V2 by R. You can just equate this to V1 minus V2 by R. And V1 minus V2 is nothing but the applied input voltage Vin. So this can also be written as Vin by R. Okay, so what is V out? It is, Vn times 1 plus 2 RF by R. I just have to plug in the values into this expression. Vn is what? 100. Okay, 100 into 2 RF by RF. I mean 1 plus 2 RF by RF. RF by R is what? 100K by 1K, which is 100. 2 into 100 plus 1, 201. So 100 into 201. Okay, 100 into 201. That is the answer. Okay, so 20,100 volts. I believe the input voltage would have been in millivolts. Okay, if the input voltage was in millivolts, then Vn will be what? 100 millivolts. Then this will be some 20.1 volts like that. Okay, whatever it is, everybody can solve this. Okay. All right, moving on to the next question. Common gate amplifier is what? Okay, common gate amplifier is what? I mean, say common gate amplifier. What is the input resistance? Common gate amplifier, the input is applied at the source. Okay, so if I just draw a transistor, in the small signal domain, if you look at this, circuit, the input is applied at the source and output is taken at the drain. And the gate will be connected to AC ground. This is a typical common gate amplifier. So when the input is applied at the gate, the input resistance is what? The equivalent resistance seen looking into the source. Okay, I meant to say input is applied at source, not gate. Okay, because input is applied at source, to find input resistance, you should look into what? The source. Generally, when you look into source, not always, but in general, when you look into source, the equivalent resistance that you see is what? 1 by Gm. And 1 by Gm is what? A very small value of resistance. And then when it comes to the output resistance, okay, for which you look into the output terminal, that is the drain. Generally, when you look into the drain, you always see large resistance. Okay, so it can be in the order of R0. Okay, so it will be R0 plus something or R0 times something based on what is the exact circuit configuration. Okay, let me write R0. Okay, the point is this: R out, it is what? A very large value of resistance. So for the common gate amplifier, you have a small input resistance and a very large output resistance. Okay, so which amplifier will generally have a small input resistance and a large output resistance? Small input resistance is suitable when the input is what? Current. Okay, so if the input is current, it is always preferable to have a small input resistance. And here R out is large. If the output is current, then it is preferable to have a large value of output resistance. Okay, so output also is what? A current. So in this way, we can say this common gate amplifier is better suited or widely, I mean, it is better suited as what a current amplifier, but then the current gain will be 1. Why? Because whatever current flows at the input terminal, that is the source, the same current also flows at the drain. Yes or no? For a MOSFET, always drain current and source current are equal. In that sense, output current is same as input current, which means the current gain is what? 1. That is why the common gate amplifier is widely used as what? A current buffer. Whatever it is, to answer this question, you have to choose option C, current controlled current source, because the output current depends on what the input current, current controlled current source. Okay. Let's move on to the next question. So again, some op-amp circuit is given. Okay. And there are a bunch of resistors as well as 2 capacitors. The capacitance value is 1 microfarad. Omega, I think the frequency of the input is given 1000 radians per second. For the above circuit, if gain is 1 volt, I mean frequency is given, but I think this 1 volt is the amplitude. Okay, so gain can be something like 1 volt sine omega t, where omega is what 1000 radians per second. Okay, this omega is what 1000, and RF and R values are also given. For the above circuit, if Vn is this sinusoid, then magnitude of V out, magnitude meaning amplitude. Okay, magnitude meaning amplitude. So I mean here all 3 op amps will be in negative feedback. Okay, because from here to here the gain is negative, and then negative, negative, 3 negatives. The loop gain is what? Negative. And also the 3 op amps will be in negative feedback. So don't worry about feedback. Okay. So negative feedback means what? You can use virtual short. Yes. So you can use virtual short and find the transfer function. The only way to find the amplitude of V out is by finding transfer function. Okay. So the transfer function is what? Like H of S, which is V out divided by V in. So after finding transfer function, you have to substitute S equal to J omega. Then it becomes like capital H of J omega. And then omega is what? 1000 radians per second. And then you should find the magnitude of the transfer function. Now the amplitude of V out will be what? Magnitude of the transfer function at that input frequency times the amplitude of the input. What is the amplitude of the input? It is 1. Okay, so it's all about finding the transfer function. Okay, so let's say how we can find the transfer function. So this block over here is what? An integrator. Okay, and this block is what? An inverting amplifier. Yes. So for example, if I call this voltage as, let's say, some VA, yes, then the voltage here will be what? Because this block is what? An integrator. Actually, I need some space to write the transfer function. Okay, I'll see what I can do. So this block is what? An integrator whose transfer function is minus 1 by SCR. So the voltage at this point can be directly written. So minus VA upon SCR. Okay. And this minus VA upon SCR will become the input for this block, which is an inverting amplifier with a gain of minus RF by R. Okay. So the voltage at this point will be this input times minus RF by R. Correct. So when you do that, minus will get cancelled, but the voltage here will be VA times RF upon SC R square. Okay. And then what is the voltage here? It is 0 because of virtual short. okay? And then you should probably write KCL at this point. Remember, this current is always 0, okay? So what is this current? Like V in by R, yes? So this is V in by R. What is this current? 0 minus this. So that will be minus VA minus of this divided by R. I think you'll get minus VA RF by SC R cube. I'm getting R cube, okay? And then you should also write this current as well as this current, okay? So 0 minus VA by RF and then 0 minus VA by 1 by SC. So altogether at this point there will be four currents, okay? At this node there are 4 currents. One current is entering, this all are leaving. So this current is equal to sum of these 3 currents, and then you can find the transfer function, that is V out by V in, okay? Alright, I'll write KCL at this point, okay? So V in by R is equal to minus VA by RF, and then the current through the capacitor will be what? Minus VA times SC, and then already I wrote the current flowing through this R, which is minus VA RF by SC R cube, okay? Also, the relation between V out and VA is what? V out is equal to VA times this. I think VA can be written as V naught. I mean, V out, I'll write it as V naught times SC R square by RF. Yes, no, VA is what? V naught SC R square by RF, okay? So in place of VA, you can write, and then you can get the transfer function V naught by V in, which is H of S, and then you substitute S equal to J omega, and then you substitute omega equal to this, and then you find the magnitude of the transfer function, okay? So I'll just write the final thing. So the amplitude of V out will be equal to what? The amplitude of V in, which I believe is this given 1 volt, times the magnitude of the transfer function. Okay, of course at 1000 radians per second, okay, you have to evaluate the magnitude, okay? Lilan, Urala, Lilan. Last 20 years PYQ is enough to get a decent rank, more than enough. If you are really thorough with the PYQs of the last 20 years, you can even get first rank. PYQs is the only thing you should be doing. So, I mean, I believe you can do this yourself. You'll get some answer, but I'll just move on to the next question. And before I hand it over to my colleagues, what is the value of IC? Okay, so this is a standard transistor circuit. You have to find the collector current. Beta current gain is given 100 and VBE is not 0.7, it is 0.65. So because the current gain is not infinite, you cannot assume the base current to be 0, okay? So what is the voltage here? It is 5 volts. So this part of the network, you can replace it with its Thevenin equivalent, okay? So without worrying about the remaining circuit, at least this part of the network, you can replace it with its Thevenin equivalent, okay, between this point and ground, okay? So what is the open circuit voltage at this point, assuming none of this is present? if you remove this while finding VOC, 5K and 5K will be in series. So the Thevenin voltage is what? 2.5. And then looking into this terminal, what is the equivalent resistance? 5K parallel 5K, which is 2.5K. So for this part of the network, there is a Thevenin equivalent. Okay. So I'll just replace this part of the network with its Thevenin equivalent, which is 2.5 volts in series with 2.5K. And then I'll draw the remaining network, which contains the transistor. Okay. There's the transistor. The emitter, you have this 5 kilo ohm. The collector also, you have 5 kilo ohm. And at the top, you have the supply voltage is 5 volts. Okay. So this is how the given circuit can be simplified. So our expected cutoff will be 25 only. I mean, why are people worried about cutoff? Cutoff will be 25 to 27. Okay. I mean, what is the reward for qualifying in GATE? Just by crossing cutoff marks, do you get anything? I don't think so. Maybe you'll get a stipend if you join some random college for MTech. Yes. Cutoff by default will be 25 plus minus. I mean, there is an easy paper. Maybe it is 27 or 28. It won't be 60 or 70. Okay. I'm just kidding. Don't mind. So VBE, this is 0.65. So this current is what the emitter current. This current is what the base current. Okay. All you have to do is write KVL around this loop. And by the way, let's assume transistor is inactive. We want to assume transistor is inactive. In the end, we'll check the condition for active. Okay. So if you write KVL around this loop, what do you get? 2.5 is equal to IB times 2.5K plus 0.65 plus IE times 5K. Okay. 2.5 minus 0.65 is what? Get 22 instrumentation 42.4. Oh, sorry, I didn't know this. Well, was it an easy paper, Chandu? Get 22 instrumentation, was it an easy paper? This side you have 1.85. So because we are assuming transistor to be inactive, we can write IE in terms of IB, right? IE can be written as 1 plus beta times IB. So which is 101 IB, okay? So IB times 2.5K plus 101 IB times 5K. So now the only unknown is what? IB. Let me use my calculator to find the value of IB, that is the base current, okay? Which is 1 second. 1.85 divided by 2.5 plus 101 into 5 is 505. 505. So the value that I am getting is this. Okay, 3.64 or 3.65, not milli, micro. That is the base current that I am getting. Okay, 3.65 microamps. That is the base current. Using this base current, we can find the collector current, right? Just multiply base current with beta, which is 100. So 365 microamps, 365 microamps, which is 0.365 milliamps. Okay. Now let's check the condition for active. So what is this current? It is IC, which is 0.365 milliamps. 0.365 into 5, sorry, into 5, and then minus 5. So the voltage at the collector, so for these values, the voltage at the collector, 5 minus the drop across 5K, I'm getting 3.175. 3.175 volts. And then you should also find voltage at the base, which we can call VB. See, definitely VB will be what? Less than 2.5. This is 2.5. And then there will be some drop in between. So the voltage at the base will be what? 2.5 minus whatever is this drop. So VB is what? Some value less than 2.5. Yes or no? You need not find the exact value, but VB, oh shit. VB is what? Some value that is less than 2.5. Okay. So VC is what? 3 point something, and VB is what? Less than 2.5. So definitely VC is what? Greater than VB. So transistor is inactive, and the collector current is what? 0.365. So the answer for this question is what? 0.365 milliamps. Okay. Yeah. Rish's electric fields are in previous question. Just do it by regular virtual short method, and using omega you will get XC, and then using KCL we can get answer. The middle op amp is acting as a buffer. Really? No op amp will act as buffer. It is not a buffer. Okay, maybe, yeah. Because of the values of C and R, it is not buffer. That is for sure. Maybe you meant to say the gain is 1. I guess you meant to say the gain is 1. Okay, for the middle block integrator, the gain magnitude would be 1, I guess. Because when you substitute j omega, right? C or omega is 1000, R is also 1000, and C is what? 1 micro. So everything gets cancelled. So in the middle portion, the gain will be 1. Okay. Maybe that will actually simplify. Okay, so new. But I don't think you can. Okay, if you substitute values, it becomes minus VA by J, minus VA by J. Okay, so this only becomes because in place of S, when you write J omega CR value is 1. Okay, so this is minus VA by J. Okay, so don't think that this VA gain magnitude is 1, so this is also VA. That is incorrect. Okay, you have to find the complete transfer function. But at least by doing this, you need not write this SCR thing every time. So that way it gets simplified. That is a good observation. Yes. So this, once you write that this is what? Minus VA by J, this becomes minus VA by J into RF by R. So you can get rid of S. You can get rid of S. Yes, that is the thing. But still you have to find the transfer function. That is the point. So this is that transistor question for which the answer is 0.365. Okay, there is a question on statistics. So on my WhatsApp, I actually received a question from one of my students. a CMOS circuit is given, okay? A CMOS circuit is given. CMOS means what? You have that pull-up network made up of PMOS and a pull-down network made using NMOS. And then you have been asked to identify what is the logic function that is implemented by the given circuit, okay? So at the top you have VDD. There is one input A. It's a 3-input gate. I mean 3-input circuit. So this input is B and this input is C. And this is the output Y. You have been asked to identify what is the logic function that is implemented by this circuit, okay? So if you look at pull-down network alone, we have one NMOS in parallel with two other NMOS connected in series. So by looking at pull-down network alone, you can write the transfer function. I mean, not transfer function, the logic function, okay? So here B and C are connected in series, so it is like B into C under the complement. And then A, it is in parallel with this thing. So you might be tempted to write, I'll just change the color. A plus, BC whole bar. A plus BC whole bar, this is what you would be tempted to write. But I think there is a problem with the given circuit diagram, okay? For it to be really A plus BC whole bar, here the input has to be C, yes? So the inputs are not applied at the right locations, okay, for the logic function to be A plus BC whole bar, okay? So this here you should have applied A, okay? And here you should have applied C, okay? So for it to be actually A plus BC whole bar, this should be A, this also should be A, okay? This is already B and this is also already B, fine. And here you have C and here also you should have C, okay? If this was the given circuit, then immediately you can say the logic function will be what? A plus BC whole bar. But this is not the given circuit. It is in white color, okay? I'll just clear this off. See, what is the idea of CMOS? For any input combination, only the pull-down network or only the pull-up network has to be active. Yes or no? Or has to be some kind of a short circuit, so the output gets connected to what? VDD or ground. In a CMOS implementation, yes, only one of the two networks has to be activated, okay? But here, for example, let us say C is 0, okay? So already I told you this is incorrect. At least for the given circuit, this is incorrect, okay? Let's say A is 0, okay? Let's say A is 1. Let's say A is 1. So here it is what? 1, okay? Here also it is 1. And let's say B is 0. And here it is 0. Here also it is 0. And let's say C is also 0. Let us say C is also 0. This is the input that is applied to this circuit. A is 1, B and C both are 0. So C is 0, here also it is 0. So for NMOS, if the gate is low, both the NMOS will be off, this off, fine. And for PMOS, if gate is high, that PMOS again will be off. But this one will be on. For this PMOS, the gate is low, this will be on. Even for this PMOS, the gate is low, even this will be on. And for this NMOS, the gate is high, even this will be on. Yes, so here you have the supply at the top, then you have two PMOS transistors connected in series, both of which are on, and then you have the NMOS that is also on. Okay. In this case, you cannot really decide whether the output will be high or low. At least for the given data, you cannot decide. If you are given information about the relative strength of the PMOS and the NMOS transistors, like for example, if they tell you that NMOS transistors are much stronger than PMOS, or if they tell you that PMOS transistors are much stronger than NMOS, then you can decide whether the output will be closer to VDD or closer to ground. But here, since the output has got a path to ground as well as a path to VDD, you cannot say for sure whether the output will be high or low. Okay, so that is why if this is the given circuit, then this is not a proper logic circuit at all. Okay, so if this is the given circuit, then it has to be marks to all. Okay. Yeah. So I think these are the questions from networks and analog. So as you can see, the questions are pretty simple. Okay. So in general, the questions will not be difficult. You think that very difficult or very lengthy questions will come, never. Okay. So always the questions will be such that people who know the subject will be able to solve. Okay. If you have that presence of mind and composure, you can easily score good marks. Okay. So I wish you all the best for the next weekend's exams, both electrical as well as ECE. Now I'll hand it over to I guess Rakesh sir. Yeah. Okay. So Hemant sir will continue. Yeah. Yeah. ఇది not. Okay.
Okay. Okay. So I think analog networks are over. Now we look at a few EMF questions. Again, the questions from EMF are quite simple, straightforward, formula based, no heavy, calculations involved here. Okay, so this is one question. We have been given VAB as some 5 volts, and we are supposed to move a charge from point A to point B. So this is the initial point, and this is the final point. This is I, and this is F. Okay. The formula for work done is given by work done in moving a charge Q from point I to point F is given by, this is Q into potential at final point minus potential at initial point. So in this context, so this becomes equal to Q into VB minus VA. Okay. Sorry. What happened to this? Yeah, so I think we have to repeat. Okay, like I've told, the work done in moving the charge, this is initial point I and this is the final point F. The work done is given by Q into Vf minus Vi. Okay, so this becomes equal to Q into Vb minus Va. Okay, so whenever we have been given VAB, obviously what is that? This is VA minus VB. So this is given as 5. So if VA minus VB is 5, what about your VB minus VA minus 5? And how much is the charge value? Charge is 1 coulomb, 1 into, this is minus 5, and the answer is minus 5 work done, so joules. Okay, so the answer that you are supposed to enter in the blank space would be minus 5. If it is given as MCQ, they will also give it as one of the option could be plus 5. So you have to be cautious in terms of the charge initial point as well as final point. Okay, yeah. So we'll go to the next question. So there is a capacitor area 2 centimeter square, distance between the plates is 0.5 millimeter. So since the area is in terms of centimeter square, so let's write even distance in terms of centimeters. 1 millimeter is 0.1 centimeter. So due to which distance D becomes equal to 0.05 centimeters. Okay, so this is the initial distance. This is the initial distance. And D is reduced by 0.1 millimeter. 0.1 millimeter would be 0.01 centimeter. So what is the value of D2 then? D2 is 0.05 minus 0.01, which becomes equal to 0.04 centimeters. So given this, you are supposed to find out how much is the percentage change in the capacitance value. Okay. So yeah, what is the value of capacitance C1 in the beginning? It is epsilon A divided by D1. Okay. So A remains same in the first case, second case. So this becomes equal to epsilon will not change because no information about change of medium. So we can safely assume medium to be constant. So area is 2 divided by 0.05. Everything is in terms of centimeters right now. Okay. So 2 by 0.05, if you do the calculation, 200 by 5, 200 by 5 is 40. So this becomes 40 times epsilon. Okay, 40 times epsilon. And what is the value of C2? C2 is equal to epsilon A by D2. And hence this becomes equal to epsilon into 2 divided by 0.04. 200 by 4 is 50. So this is 50 times epsilon. And what you are supposed to find out? Percentage change in the capacitance. So percentage change in capacitance is given by how much? This is C2 minus C1 by C1 into 100. Final minus initial by initial into 100. And this becomes equal to difference is 50 minus 40. So this is 50 minus 40 divided by 40 into 100. And this turns out to be 10 by 40, 1 by 4 into 100, 25 in terms of percentage. Okay. So the percentage change would be equal to 25%. Okay. Yeah. Yeah. Next. So electric field has a potential. This should be given as potential, electrostatic potential value of so and so. And a charge of 1 coulomb, there is a 1 coulomb placed at a particular point. This is memory based, so the question will not be as such. At a point having position vector so and so, and the experience of the force experienced by the charge, 1 coulomb charge, is given by A x cap, B y cap, and C z cap. Then what are the values of A, B, C? So that is the question all about. So what is the logic? The force acting on a charge Q is given by Q times electric field. Okay, but do we have the electric field expression? No, but we know how to write electric field in terms of potential. So this becomes equal to Q into what is electric field E in terms of potential? Negative of gradient of V. Okay, that's it. So this is all about in this question. And finally, this becomes equal to minus Q gradient of V. Okay. So here, if you are comfortable in converting the given potential from rectangular to spherical and do the calculation in spherical, reconvert the answer back into rectangular, yeah, then that is one method. Or if you say ki ha sir, I'm comfortable in rectangular only, then that is one more method. So I'll do both methods. So in gradient we'll have differentiation of the function v with respect to some variable x. Okay, so this is the function. If you differentiate that with respect to x first, what will you get? Half x square plus y square plus z square whole power minus half into differentiation of x square, which becomes equal to 2x. Okay, so 2 is gone, 2 is gone. So this becomes equal to x by square root of x square plus y square plus z square. By means of symmetry, we will have differentiation with respect to y as what? Y by square root of x square plus y square plus z square. And with respect to z, differentiation with respect to z as what? Numerator is z, denominator is square root of x square plus y square plus z square. Okay. And substitute that here, we'll get minus q into, so dou v by dou x, x cap, plus dou v by dou y, y cap, plus dou v by dou z, z cap. Okay. Now substitute the point. If you look at the position vector, what is the point now? It is 1, 1, 1. If you substitute the point 1, 1, 1 here, what will you get? This is 1 by root 3. And what do you get for the differentiation with respect? I'm sorry, this is with respect to, the same thing happening. I think I've done some mistake here. Okay. I just have to repeat. I'll just write the formula directly. Okay. Just go back previously as to what happened earlier. So we are supposed to calculate force. Force is given by Q times electric field expression E, and this becomes equal to Q into negative of gradient of V. And for the given function, if you take dou V by dou X, we have got it as x by square root of x square plus y square plus z square. And from the given point or position vector given to us, this is 1, 1, point. And if you substitute the point here 1, 1, this becomes equal to 1 by root 3. Okay. And how much is the value of charge given? Charge is 1 coulomb. So this becomes equal to minus 1 into, here we'll have differentiation with respect to x, 1 by root 3, x cap plus 1 by root 3, y cap plus 1 by root 3, z cap. That's it. So, from this, if you see what is the value of ABC, ultimately, the coefficient of x cap is minus 1 by root 3. So from this, A is equal to B is equal to C. All three guys are same, and that becomes equal to minus 1 by root 3. Okay. Yeah. So this is all about in this question. Very simple question. It is basic definition of Lorentz force acting on a charge present in the present in some kind of electric field. But only thing is, electric field information is not directly given to us. We are supposed to calculate electric field by using the potential information given. Okay. Okay. So what is the volume charge density? Very simple question. Gauss law. It is simply based on Gauss law. What is the formula for rho v? Rho v is equal to del dot d. We don't have d information. We have electric field E information. So this is E times epsilon times del dot E. So it is divergence of electric field. When you take divergence of this, what do we get? In rectangular coordinate system, the formula for divergence is given by dou E x by dou x, dou E y by dou y, plus dou E z by dou z. Okay. So who is this guy? This is Ex, and the coefficient of y cap is Ey. The coefficient of k cap is nothing but Ez. Okay. So if you differentiate Ex with respect to x, this is y and z terms gone. All you'll have is 2 here. If you differentiate Ey with respect to y, we'll have 4 here. If you differentiate Ez with respect to z, we'll get 2 here. So 2 plus 4 plus 2, the answer is how much? I think 8. So this is 8 epsilon. If nothing is mentioned about the medium, we can assume, yeah, anyway, I think it is given as free space. Yeah, the medium is given as free space. So epsilon becomes equal to epsilon naught. That's it. So a very, very straightforward question. Okay. Next, again, another question on Lorentz force equation, but with respect to magnetic fields. A twin wire carrying a current of I is equal to so and so in some direction is placed on, I think this is a thin wire, not a twin wire, but rather a thin wire. Okay. In some direction is placed on magnetic field. If you notice, this is a unit vector, which simply indicates direction for us. Magnitude becomes equal to 1 there. And magnetic field is given by some 2I cap plus 2K cap Tesla. The force per unit length on the wire is dash. Okay. So what is the force acting on a current carrying conductor carrying a current of I in the presence of magnetic field? This F bar is given by, it is given by, this is I into L bar cross B bar. Okay. Where I is nothing but total current carried by the conductor. L bar indicates the direction in which the current is flowing. And it also has information of length. But I don't have the information of length. Okay. In this case, I want to calculate force per unit length. So I can write this as this is I into length L into N cap cross B bar. And I can take the length outside and then I'll get F bar by L, which becomes equal to what? This is force per unit length. Force per unit length is given by I. How much is the value of I? I is 1 ampere, 1 into N cap. N cap is given by some 1 by root 6 X cap cross. X cap plus 2 by root 6 Y cap plus 1 by root 6 Z cap cross the magnetic field B bar, which is given by 2 X cap plus 2 Z cap. 2 Z cap. Okay. How much is this? See, here you are supposed to know the cyclical order of unit basis vectors, that is X cross Y becomes equal to Z, Y cross Z becomes equal to X, and finally Z cross X becomes equal to Y. If you have anything in reverse, it becomes equal to minus of whatever you have got here. And if you take cross product of vectors which are of same direction, then answer is 0. So X cross X 0, X cross Z becomes how much? We have Z cross X Y, means X cross Z is minus pi. So 1 by root 6 2. So minus Y component, we have got Y component as basically minus. I'm taking minus inside because we can have another term also. So because which 1 by root 6 2. So minus 2 by root 6. Okay, one of the terms. And then X cap will get terms, Z cap will get terms. So let's try to verify. X cross X 0, X cross Z, we have got minus Y, so minus sign, magnitude 2 by root 6. Okay, now with respect to Y, Y cross X, X cross Y is Z, so Y cross X is minus Z, so minus 2 here and 2 here, 2 into 2 is 4, so minus 4 by root 6. Okay, yeah, next, Y cross Z. What is Y cross Z? Y cross Z, as you can see here, X. So we have one X component now, 2 and 2, 4. This is 4 by root 6 plus sign, plus. Okay. Z cross X is Y. So now we have got a positive component of Y. 1 by root 6, 2. So this is 2 by root 6. Okay. So Z cross X plus positive term here. Z cross Z is 0 anyway. So remaining terms are 0. Nothing else we have. That's it. The first one is entirely gone. So we'll have only X and Z terms. So what is the final answer from this calculation? It is simply cross product anyway. So we have got 4 by root 6 X cap minus 4 by root 6 Z cap. Okay, so we should have only x and z terms. So answer A is wrong, answer D is wrong. Yeah, in option B and C, we only have, yeah, I think 4 by root 6 x cap and 4 by root 6 z cap. Yeah, this is the correct answer. Okay. So if you see, quite a simple question if you know the formula for Lorentz force, okay, in magnetic fields. We have a couple of questions of even measurements. What is the power in the circuit of current I is equal to so and so number and voltage also so and so number? Okay. Okay. So you are supposed to express the power first. What is the formula for power? Power is given by some V into I. Okay. And using that, this is 100 milli and this is 5 volts. When you multiply both of them, this becomes equal to 500 milliwatt. Oh, every option we have 500 milliwatt, so that's not a big deal. The problem is in finding out the percentage error in power. How much is the percentage error in power? Del P by P. Okay, how much is that value? It becomes equal to, since both of these terms are in product format, it becomes equal to del V by, that is percentage change in voltage, del V by V plus del I by I. If you take into 100, it is percentage error on both sides. Okay. So how much is percentage change in voltage? It is 5%. So 5% here plus how much is the percentage change in current? It is 2.5%. So the percentage error gets added up when it is multiplication or division also. So the answer is 7.5%. 7.5% of what? Of your actual measurement. Okay. So 7.5% of 500 milliwatt. How much is this number? 7.5 by 100 into 500. This is absolute terms. If you do the cancellation, this turns out to be 37.5 milliwatts. So this is the worst case error that we will have. Okay, because this is MSQ question, you are having more than one correct answer here. Your option B is definitely correct. 500 milliwatt plus or minus 7.5%. Okay. And if you're talking in terms of absolute numbers, what is 7.5% of 500? That is 37.5 milliwatts. So even this is also correct. Okay. So this question has two correct answers, B and D. Okay, this is a MSQ question. Okay, so Lissajous patterns on CRO has 3 horizontal tangencies and 2 vertical tangencies. And we are assuming that they are full tangencies, they are not half tangencies, none of them are half tangencies. If the horizontal frequency is given as 600, then what is the vertical frequency? See, we have a formula Fy by Fx becomes equal to the ratio in reverse, the ratio of tangencies in reverse. Okay, so this is equal to number of horizontal tangencies by number of vertical tangencies. Okay, so x is horizontal, y is vertical. If you take, then horizontal tangencies is 3, vertical is 2, and I think frequency in horizontal direction is given as 600. So then Fy becomes equal to 3 by 2, which is 1.5 times 600. I think this becomes equal to 900. Okay, so this is what we have in this question. Yeah, we have got these two questions, I think, in measurement. Yeah, with this we are done with both EMF as well as also measurement. The kind of questions that you got, like I always say in all my classes, that in this subject, this is one of the important topics, work done calculations by using point charges, very commonly asked. And apart from that, capacitance and inductance questions also are very important topics. And this is one more, using potential to calculate electric field. I would definitely say this is basically calculation of potential or calculation of electric field by using potential. Again, another important topic. Gauss law, Ampere's law questions. This is Gauss law question. Similarly, we also have Ampere's law. Straightforward, very simple questions. Rho V is equal to del dot D here. J bar is equal to del cross H in case of Ampere's law. That's it. we have got straightforward questions just based on that formula. Okay. Yeah, again another Lorentz fourth equation question. Okay, so these are quite repeated questions that we get generally in EMF. Okay, even in electrical and EC branches, these are some of the important topics I'm expecting. A question on Gauss law, a question on Ampere's law, questions again on inductance and capacitance calculations. Okay, again, this is a very easy paper. Don't assume that electrical and EC papers will also be equally easy. We cannot predict how the paper might be. Okay, because last year the paper, instrumentation paper was quite tough, but rather if you see the EC paper was quite easy to moderate kind of. Okay, I wouldn't say so easy, I wouldn't say at the same time kind of easy to moderate kind of a paper. So, don't assume that paper might be easy or paper might be tough. We can't say. Okay, every paper is definitely unique. So, we can't predict the toughness level of the EC as well as the triple papers on the basis of instrumentation paper. Okay, yeah, all the best for your next week electrical/EC papers. Do well. Okay, and Rakesh sir will now discuss questions on control systems next week.
Controls and maths.
Controls and maths. Yeah. Okay.
Thank you, sir. He has gone, he'll come back. Just a second, students. Okay, yeah guys, control system again, I've got 3 questions, easier side only. Okay, what is there? LTI's unity feedback system has GS given to you, system is subjected to unit ramp input, unity feedback it is, so I can define the type. Okay, it is S power 1k, so what type it is? Type 1. Okay, it is type 1, that is why the error they are asking due to unit ramp input. Okay, steady state error due to unit ramp input will be given by what? 1 upon kV. Okay, because of step it will be 0, because of parabolic it will be infinity. Okay, what is the value of kV now? Okay, limit s tending to 0, s into gs. So when I calculate this limit s tending to 0, s into gs, that is 10s plus 1 divided by s square plus 2s plus 5. Okay, s will get cancelled and the answer is 10 into 1 divided by 5. When I put s tending to 0, it is 2. So what is the final answer? 1 by 2.5 if it was NAT. Okay. Yeah, guys. Okay. All right. Next. If GS is K upon S plus 1 power 4, what is, and the gain margin is given. Okay. What is the value of K? Okay. See, first of all, what is the GJ omega? K is divided by 1 plus j omega power 4. Okay, gain margin is calculated at what? It is always calculated at omega p, phase crossover point, phase crossover frequency. Okay, what is angle GJ omega? The angle of this numerator is what? Positive real number. So minus 4 times 1 plus j omega phase is nothing but tan inverse omega. Okay, and if I put omega as omega p, it should be equated to minus 180 degree, right? Okay, so 4 got cancelled, minus got cancelled. You have tan inverse omega p is nothing but 45 degree. Okay, so what is the omega p? Omega p is tan of 45 degree and that is nothing but 1. Okay, so what is the value of omega p is nothing but 1, correct now? Okay, now omega p is 1. Okay, now gain margin. What is the gain margin? It is given by 20 log 1 upon magnitude at omega p. 1 upon mod gj omega p. Now what is this magnitude? If I write down the absolute magnitude, mod gj omega will be k. Now 1 plus j omega power 4. Okay, so under root 1 plus omega square power 4. So 1 plus omega square whole square will be left. Okay, now 1 plus omega square whole square will be left. Okay, so when I write down this value, 20 log reciprocal of this will be 1 plus omega square whole square divided by k. Okay, and what is the omega you have to put? Omega is the omega p we have to put. Okay, it is calculated at omega p. Omega p is 1. Okay, so when I put the value of omega p, I get 1 plus 1, 2. 2 square, 4. Correct, na? Yeah, so that is going to be 4 by k. Now what is given to me? It is given as 20 only. Okay, 20 log 4 by k. The gain margin is given as 20. That means log of the value is 1. So 4 by k has to be 10. Okay, so that log 10 is 1. Then what is the value of k? 4 by 10, 0 0.4. 0 0.4. Okay, 0 0.4, right? 0 0.4. Okay. Yeah, then see, if you are telling poles on imaginary axis, then it has to be MCQ question. Then it has to be MCQ question. Okay, I will check that possibility. Okay, since the data was a NAT type of data, so I started calculating it. Okay, if it is MCQ, then some option will be there. See, what is there? If you write down the characteristic equation, what is going to be there if you write down the characteristic equation? It will be 1 plus 10 s plus 1 divided by, okay, s square plus how much? 2s plus 5 equal to 0. Correct, na? So what is that characteristic equation? S cube plus 2s square. Correct, na? Sorry. 2s square. Then 5s and 10s. 15s plus 10 equal to 0. No, it's not going to be on imaginary axis. It is stable only, na? Then only NAT question can come. Otherwise, if it is, marginally stable, the indeterminate, okay, then indeterminate can only be written in options. Let me check the calculation again. Okay, this is going to be s cube, then plus 2s square, plus 5s, plus 10s, that is 15s, and plus 10 equal to 0. Okay, yeah, very clearly for this equation, BC minus AD is positive. 2 into 15 is greater than 1 into 10. It is stable system only. Okay, it is stable system only. It is a NAT, yeah, that const learner is telling NAT. NAT means it has to be, having some numeric answer, right? Otherwise, if it is MCQ and then they provide the option, see, where you have to be careful. If it is MCQ and the given steady state error is indeterminate. In case of marginally stable, indeterminate. If it is unstable, steady state error unbounded. So when such options are there, of course, we have to be careful. Okay, so generally we have to be careful. But if it is NAT, why to waste time? Okay, if it is NAT, why to waste time? We have to get an answer. That means the system has to be stable. Unbounded also means what? Infinity. You cannot fill infinity in the NAT answer. Okay, so anyways, this is correct only. Okay, right. Anyways, this is correct only. Got, Kiran? Okay, yeah. So this is also done. K is equal to 0.4, right? What else is there? Okay, a system has been given. Do you find the poles of the system? Okay, do you need to find the transfer function? Absolutely not. What are poles? Simply, poles are also equal to eigenvalues of the matrix A. Okay, for the matrix A, what is the characteristic equation? What is the characteristic equation for a 2 cross 2 matrix? Okay, you can find by mod A minus lambda I equal to 0. Modulus of A minus lambda I equal to 0. But 2 cross 2 many times. You can link it with the maths concept also, this control system question. Many times I have told you the direct 2 cross 3 because 2 cross 2 systems, 2 cross 2 matrices and 3 cross 3 matrices are very common in data. Okay, so lambda square minus trace. What is the trace? Minus 7. What is the determinant of the given matrix? 0 minus minus 10. The determinant is 10. Okay, so what is the overall equation? Lambda square plus 7 lambda plus 10 will be equal to 0. So lambda will be how much? Factors are plus 5 plus 2. The lambda is minus 2 and minus 5. And that is also equal to the poles of the system. That is also equal to the poles of the system. Directly you can do that. Okay, directly you can do. Just the matrix characteristic equation is enough to comment on the poles of this control system. Okay, what is there? See, a basic integral question. Okay, you can call it as signals or maths, anything. A function of time is given. What is that function of time given? Okay, we'll draw it very carefully. It's not given any type of twist in any question. Okay, what is there? Ft equal to 1 for t belonging to 0 to 2. Okay, for t equal to 2, 3, a line. T equal to 2, 3, a line of negative slope. Let me check the continuity. When I substitute t equal to 2 here, minus 2 plus 3 will be 1. So yeah, it will be continuous here. Okay, and then it is a line with decreasing line because negative slope. How much slope? The magnitude of slope is 1. Okay, so this goes up to 3 and this is 3. Yeah, correct. Height upon base 1. Satisfied. Slope equal to 1. This is the height and this is the base. Okay, what is the area? What is this integral is also equal to area. Okay, what is there? This childhood question. Okay, just find that. I have to find the area, height into base. Okay, for this part, for the rectangular part. Okay, then for the triangular part, half into base into the height. Both are 1 each. Okay, So 2.5, 2.5. Check your answer. 2.5 it is, right? 2.5 it is. Next. Okay, fx equal to x mod x. What is fx? You have to check continuity and differentiability. 4 options would be there. Okay, continuous, not differentiable, continuous and differentiable, something like that. 4 options will be there. Okay, so what I'm going to check here is fx is x into mod x. See, if it was only mod x, then you know at x equal to 0, and that too the continuity and differentiability must be asked at x equal to 0 only. Okay, otherwise, so for sure it will be continuous and differentiable. If it was only mod x, you know it is continuous but not differentiable at x equal to 0. It has that sharp point. But x into mod x, okay, let us understand. How do you write down mod x? When x is positive, mod x is anyways x, so it becomes x square. But when x is negative, mod x is minus x. So overall function is minus of x square. Overall function minus of x square. Now see, whether you see the value of the function from left side or whether you see the value of the function from the right side. Another way you can draw the graph also. But okay, left hand limit at x equal to 0. Okay, x equal to 0 minus of x square. But when you put 0, it will be 0 only. Sorry, this is right hand side limit. Left hand side limit for x less than 0, the function is minus x square. When I put x equal to 0, okay, I get again 0. The LHL, RHL are same only. LHL, RHL same. Even the value of F0, 0 into mod 0 will be 0. Okay, LHL equal to RHL equal to F0, the continuity is there. Continuity is there. Okay, many students here, okay, as far as I noted with discussions, were slightly confused about differentiability. See, what is the derivative of this function? What is going to be the derivative of this function? Okay, x square derivative, 2x. Minus x square derivative, minus 2x. This is for x greater than equal to 0. This is for x less than 0. Okay, so I can also say that the derivative of this function, if you take 2 outside, x and minus x again makes a modulus x function. Okay, right, or you can draw the graph. Okay, what is the f dash x function? It is this f dash x function is a modulus function. Okay, 2x here, slope 2 and minus 2x here. Is it not continuous? Okay, now I'll tell you 2 things. Okay, is it not continuous here? Okay, so the f dash x, the derivative is continuous at x equal to 0. Derivative is continuous means what? Means fx is differentiable. That is one way of understanding differentiability. Na? A function is differentiable means its first derivative must be continuous at that point. Okay, otherwise what you can do? Okay, or what you can do? You come up here. This is the derivative. Tell me the left hand derivative. Okay, tell me the left hand derivative. The value of derivative from left side is minus 2x. Okay, I'll put x equal to 0 because I have to check at x equal to 0. So again 0. What is the right hand derivative? The right hand derivative of the function is 2x. At x equal to 0, it will be again 0. What is there? Same, na? So it is differentiable. Anyways, you can comment. It is continuous and differentiable both. What is the function? It is both continuous and differentiable at x equal to 0. Okay, at x equal to 0. See, many times students are asking about how the EE paper will be, how the EC paper will be. Okay, nobody knows except IIT, nobody knows. Okay, don't stop thinking about this. Okay, imagine today paper not happened. What was your state till yesterday? What was the state till yesterday? That you have to prepare in all dimensions. You should be able to attempt any type of question. Okay, last year IN paper was difficult, but EC was easy, or if not easy, easy to moderate, but it was not tough at least. Okay, so what is there, guys? And even EE paper last year was not difficult also. It was just moderate. Okay, this year IN is easy. Maybe ECEE both are equally easy. Maybe one of them is difficult. Anything can happen. You prepare as you were preparing till yesterday. What is the other thing? You do your best. Okay, but if it is easy, it will be easy for all. If it is difficult, it will be difficult for all. Only go with that mindset. Okay, don't make any assumptions with respect to IITs. You can't predict actually. Okay, number of solutions of the above equation, a linear system of equation AX equal to B. I've got this data directly. Okay, but yeah, some linear system of equation AX equal to B type will be given. See a very simple way of answering this question. Okay, I don't know how much marks this question was. Okay, but if you have seen my classes, you know how to answer it. Okay, rather than solving, applying the calculation of rank, echelon method, nothing required. You simply see here, okay, when you are going to write down this in terms of equation, see, what is the equation? X plus 2z. Okay, x plus 2z equal to 1. Next equation, minus x and plus y, z is not there, equal to 3. Third equation, Okay, third equation is y plus 2z, x is not there, equal to 0. Okay, I have the three equations given to me. Okay, if I am adding first and second equation, see why that intuition comes to my mind, because when I add these two numbers, 0 plus 1 is 1, 2 plus 0 is 2. Because of that reason, I got that intuition, okay, I will add it. Okay, when I add 1 and 2, what will get? X and x cancel. Okay, only y will come. Only 2z will come. But equal to how much? 1 plus 3. I have to add the right side also, no? Equal to 4. Okay, but what is equation number 3 telling? Okay, y plus 2z equal to 0. Y plus 2z equal to 4. Whom to trust? Someone is wrong. Contradiction. The system of equation can never be solved. No solution. So if they have asked number of solution, it has to be 0. It has to be 0. Contradiction case. Okay, contradiction case. Done? Easy. Okay, easy. Right, for a 3x3 matrix, see, I've got this partial question. Okay, there is this characteristic equation given. Definitely, this must be characteristic equation. Okay, where I is the 3x3 identity matrix. Then what are the possible eigenvalue? Now, see, remember, okay, you will not be solving cubic equation. You don't have that cubic calculator. Okay, so can anybody let me know what options are? Because some of the options are single eigenvalue, this double eigenvalue. I think something may be missing. Or was it a MSQ question? Different eigenvalues spread over different option. Okay, if anybody remembers, you can let me know. Okay, see, what I can simply say is, okay, this is the characteristic equation. Okay, characteristic equation means it is written in terms of P. I can replace P by lambda. Okay, it's like Cayley-Hamilton theorem type of result given. Okay, what will be the characteristic equation? I'll write this way: lambda square, lambda cube minus 4 lambda square plus 5 lambda minus 2 equal to 0. Okay, now whether 2 is the eigenvalue or not. Okay, if I have to go option, if this is the only thing given, okay, these are the current option. Okay, if there is any correction in option, you have to tell me. Okay, so what is this? What is 2 cube minus 4 into 2 square plus 5 into 2 minus 2? How much it is? 8 minus this becomes 16 and plus 10 and minus 2. Total how much? 18 minus 2, 16, 16 minus 16. Yeah, it is satisfying 0. Okay, so this looks a correct answer. Now that's what I'm telling. Maybe it is MSQ. Maybe it is the MSQ. What is there? 3 cube minus 4 into 3 square plus 5 into 3 minus 2. Okay, that is nothing. 27 minus this is how much? 36 plus 15 and minus 2. How much this becomes? Okay, this is not coming to be 0. Correct, na? 42, 40. No, this is not coming to be 0. Check the calculations again. I think it is okay. Only 4, 9, 36, 3 cube. Yeah, this is not coming to be 0. Okay. Okay, so definitely B is not the answer. Okay, whether 1. Okay, so if 3 is not the answer, this also will be wrong. This is also wrong. Okay, 1 and 2. Okay, if you talk about 1 and 2, then okay, is there anything that you're commenting on option? Mr. Unlucky says D would be 113. Okay, you're telling D would be 113. 113. Okay, we'll check it. Okay, we'll check it. First, we have to verify 1. Okay, if I substitute 1, okay, 1 cube minus 4 into 1 square plus 5 minus 2. Okay, yeah, this is going to. Did I say right, wrong? No, correct. Lambda is 1 only. No, 1 minus 4 plus 5 minus 2. Yeah, this definitely satisfies. Okay, this is 0. Okay, so 2 is also there. 1 is also there. 2 is also there. Okay, this is what I know. Okay, 2 is there. 1 is there. No, then it will not be 1 comma 1 comma 3. Those are inside set. Answer is 1 and 2. Yeah, 1 and 2 is that is what satisfying. Okay, 1 also satisfied, 2 also satisfied. Okay, 1 also satisfied, 2 also satisfied. So see, that you have to tell me. Okay, 3 not satisfied. Okay, 1 and 2 satisfied. Okay, 1 and 2 satisfied. So then you have to check and let me know. Okay. Not MSQ. Not MSQ. This option, it is not MSQ. Okay. Acha. Suppose if I want to find the third also, now I can find third. These two are satisfied. Now you see. Okay, remember, what is product of lambdas is equal to determinant. And in this characteristic polynomial, this term is nothing but determinant term. Okay, this term is nothing but the determinant term of the matrix. Okay, the product of lambdas, one of them is 2, one of them is lambda. Third, suppose I don't know, but determinant is 2. Okay, so lambda equal to 1. Okay, so what are all the eigenvalues? 1, okay, 1, 2. Okay, that means 2 of the eigenvalues are 1. Okay, so if option number D is 1, 1, 2, it would be right. Okay, so that you have to check. Otherwise, 1, 2. Otherwise, 1, 2. Got my point? Got my point. Next question. How much easy question from contour integral? How much of easy question it is? Okay, this given contour C, whatever it is, it contains 1 comma J0, 1 plus J0. Okay, why this is important? Because the only pole or singular point of the function is Z equal to 1. Okay, inside or outside, clearly data mention it is inside. Okay, so if it is inside, what is the residue? Then I will calculate residue, otherwise I will not do anything. Okay, what is the residue at Z equal to 1? Okay, simple pole of first order, limit Z tending to 1, Z minus 1 into Fz. What is Fz? Z square plus Z square plus Z plus 1 upon Z minus 1. So Z minus 1 cancelled. 1 plus 1 plus 1. Residue is 3. Okay, the value of integral is given by 2 pi I into the residue. Okay, 2 pi I into 3. So answer is 6 pi I. It should not be NAT, dear. Otherwise, some divide by 2i type of thing should be there. Okay, 6 pi I correct answer. It should be MCQ then if the answer is in, I. If the answer is in terms of I, 6 pi I. Okay, then it will be MCQ question. Got my point? Next question. Okay, yeah, this is one question of differential equation. Okay, that little bit logic you have to apply to come up to the answer quickly. See, what is the type of equation given to you? Okay, right side there is no function. Even if I try to solve, okay, right side 0, pi will be 0. So only what is required is CF. And for CF, I need auxiliary equation. For second derivative, m square will come. Plus 1 equal to 0. M square is minus 1 or m equal to plus minus I. Okay, right. So roots are pure imaginary. If roots are pure imaginary, what will be x function? Okay, x is a function of t. Okay, it is like alpha plus minus I beta, complex conjugate pair, e power alpha, that is 0. Okay, C1 cos beta t, beta is 1, C1 cos t plus C2 sin t. This is the answer. Then I need to check the options which is talking about derivative. See, this is nothing but, of course, you don't directly study in your syllabus. That's why we are solving the differential equation. Okay, that's why you're solving the differential equation. But what is there? This is related to the concept known as simple harmonic oscillator. Okay, but okay, what is there? What is the first derivative? X dot we have to check now. What is the first derivative of this? Tell me. What is the first derivative of this? Okay, so the first derivative of this is going to be minus of C1 sin t plus C2 cos t. Okay, now when I take the mod of x dot square plus mod x square, that is what the options are trying to ask you. Now see, you can skip many of the calculation because when you apply the square here, when you're going to apply a square here, this is going to be C1 square here also, sin square plus cos square 1. Here also C2 square common, cos square plus sin square 1. Okay, then here it is minus 2C1 C2. Okay, sin t cos t plus 2C1 C2 sin t cos t, that is going to be 0. That means answer is going to be some constant. Okay, answer is going to be some constant. Yeah, answer is going to be some constant. Or that is what it is, option number A. If this is what is the correct data. Okay, are you talking about this question as MSQ, Vishnu? Okay, are you talking about this question as MSQ? It can be 0 under certain case. Okay, it can be 0 under certain case. Okay, but not, in general. Okay, but not necessary in general. Okay, right. So it is not a general answer. Okay, here it is e power jt, not a function of time. If I say modulus of e power jt here, then that also becomes constant. Okay, so yeah, as per this A option, as per this much information, it has to be option number A. Option number A, right? Okay. Yeah, option number A. So guys, already we updated you about our offline courses, online courses. If you are, offline courses, I updated you. 26th Feb is the first offline batch. Then online batch, okay. 2nd February it has started and we'll announce one more, online live batch after the GATE exam. Okay. So if you're not able to manage for offline, if you're not able to travel to Hyderabad and study from your own place, you can also, refer to our online live course. Okay, analog already discussed. All these questions are analog discussed by Gautam sir. Okay, what is there? Okay, some very basic aptitude questions are there. x0 not equal to 0. See, x0 not equal to 0, they might have given Mukherla. It is MSQ. Now see, that's what, if it is MSQ also, okay, and if there is any other data, right now only one option looks correct only. Okay, right now only one option looks correct. Okay, and that we have to see. Okay, see what they have told x0 is not equal to 0. Now what is going to be x0? X0 will be simply C1. Yeah. So see, now that again is an important data here. If you are telling additional data given, x0 not equal to 0, you are telling, na? Okay, so what is going to be x0? Sign term will be 0, only C1 will be left. Okay, that means C1 is non-zero. Now if C1 is non-zero, the 100% final answer will not be 0. This is now eliminated. So only one option then. Okay, then this is eliminated only. Okay. Okay, right. What is the data, additional data you mentioned to me? X0 not equal to 0 given, and this will tell you C1 not equal to 0. Okay, C1 not equal to 0 means overall this constant will be non-zero constant only. Okay, then this will not come. Okay, then this is not going to come. Okay, yeah, this is analog already discussed. If you have not followed, you can go back to the video. Okay, what is their median? Simple data. Okay, how much data it is? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, odd number data, easy only. Only thing is the data has to be arranged in a ordered manner. Okay, so -3, then I see -1, then I have 2 zeros. Okay, then what I see 1, 2, 3, 3 times 1 and then a 2. Correct? Na? This is the data. This is the data. Okay, so now 4, this is 8 or 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. What I missed? -3, -1 is also once. Okay, -3, -1. What else is there? 0 has been written twice. Okay, 1 is there. Okay, and 2 is there twice. Okay, so see, these are 4 numbers, these are 4 numbers. This is what is your median. Finished. I was not expecting they're going to ask this one simple case. Okay. Yeah. No, e power jt modulus is not given, na Vishnu? Okay. If it is e power modulus jt, e power jt modulus given, then it could be answer. That's what I told you. Next one. What is there? Simple, yeah. 2nd June is Thursday, then 3rd July. Obviously, data is this much, but it should be same year. Okay. It has to be same year. Otherwise, how many years are there? Without that, we can't answer. Okay, so what is there from 2nd June to 3rd July? Okay, how many odd days are there? Okay, how many number of days are there between 2nd June to 3rd July? So in June 30 days are there, na? So -2, 28 days of June, and we are talking about 3rd July. So this is 31. Okay, now see, no need to go for odd days also. This is complete 4 weeks. Normally, how we find the odd days? Okay, this is the odd days. I mean, normally we find by dividing the total number of days. If it is a large number, finding the remainder of total number of days by 7. It's a very small data, out of which 28 is 4 weeks. Okay, 3 odd days. If it is 3 odd days, the answer is what? Your answer has to be Thursday plus 3. So what should be Thursday plus 3? Nothing but Sunday. Okay. Simple question, simple. Okay. 2 fruits are randomly selected and the data I tallied with the student, it is without replacement. You can let me know. Okay, because this much I got first and then I tallied, so it is given as without replacement. Okay, 2 fruits are randomly selected in a lot of 3 apples and 2 oranges. What is the probability of getting an apple followed by orange? Apple followed by orange. What is there? Probability of getting apple 3 by 5. Okay, now because without replacement. Okay, oranges are intact too, but because it is without replacement, 1 fruit is with you. So how many fruits are there in the bag now? Okay, only 4 because total 5 are there. Okay, so it becomes how much? It becoming simply 6 divided by 20, or that is 0.3. In this case, 0.3 is the answer. 0.3, 3 by 10, yeah, whatever you say. Correct? Okay, 0.3 is what is the correct answer. All okay, dear? 0.3 is what is the correct answer. Simple question. PQRS having different ages made the following statement. Okay, basic arrangement question. P says that I am younger than S. Okay, Q, I am neither oldest nor youngest. So that means when I make the sequence, Q is neither oldest nor youngest. So Q has to be somewhere here. Okay, R says that P is older than me. Older than me means greater in age. Okay, so when I combine these two, who is the youngest? When I combine at least these two, let me write reverse, R less than P and further P is less than S. Okay, now see, RPS, this one sequence is there. Can this be RPS on the first 3 position? No. If RPS on first 3 position, Q has to go to the last, which is not possible. Q is at the center. Okay, Q cannot go last. So that means only possibility S has to be at the last. Okay, and then R has to be at the beginning. Then only the sequence will come. Okay, right. R has to be at the beginning. So now what is there? Out of these two, P or Q, anything that is missing and we don't want. Who was the youngest? Youngest is R. If they ask eldest, eldest will be S. Correct answer, right? Simple one, easy one. Okay. Now this one you have to say whether the data is correct or not. Okay, what is the data? ABC are centers of circle with radii R1, R2, R3 respectively. Some R1 is 2 centimeter, some R2 is 1 centimeter. What is the value of R3, the radius of third circle? Angle ACB is 90 degree. That means a right angle triangle is given. Okay, now because angle ABC is right angle, you have to simply apply AB square, that is becoming hypotenuse, will be equal to how much? Okay, this is C. This should not be A then. Okay, is equal to AC square plus the BC square. Okay, just tell me whether the data is correct or not. You have to just tell me whether the question, whether this data is right or wrong. Okay, because if this is right, to AB becoming how much? If I assume this as right, AB becoming 3. Okay, what about AC? Okay, AC becoming, this is again 2 and this is your radius R3 only. So this is going to be R3 plus 2 whole square. Okay, what is going to be then the BC value? Okay, this side is again R3. Okay, so this is going to be R3 plus of 1 whole square. Okay, then you have to solve the equation. Correct only? Acha, Vishnu says correct only. Okay, so then what is there? This is 9. Okay, R3 square, total 2R3 square. Okay, plus 4 plus 1 plus 5. Okay, 2AB. So 4R3 here and 2R3 here. 6R3 total. Right now? 2R3 R3 square, then 4 plus 1. This is 5. And this is 2AB, 4 to 6. Okay, then if I want to simplify, what else I have? 2R3 square plus 6R3 and minus 9 this side. So minus 4 will be equal to 0. Cancelling 2. So R3 square plus 3R3 minus 2 equal to 0. Okay, plus here and minus here. Of course, so then what should be R3? Okay, it is going to be minus B plus minus root over B square minus 4AC. Okay, this is B square minus 4AC. So minus 4AC will become plus 8 and that is divided by 2 into 1. Okay, so answer is minus 3 plus minus root over of 17 is divided by 2. That you can calculate. Answer will not be negative. Okay, radius it is. So it has to be minus 3 plus under root 17 plus root over 17 divided by 2. That you can calculate. Okay, but mostly if it was aptitude question, it will have options. Okay, it will have options. Acha, that cube one, okay. I think cube one, I don't have the question here, but what I heard from student, some question on Fibonacci series it is. It is not a cube question. Okay, it is some cube with some dots written and that dots are following the pattern of Fibonacci series. Okay, that one I think you're trying to say. That one I think you're trying to say. Okay. See, one more question Vishnu is adding here. Okay, I will take that question. What is the question you are telling Vishnu? X square minus 2xy plus y square will be equal to 1. Okay, this represents what? Okay, so what is this? Nothing but x minus y square identity na, equal to 1. So what is the x minus 1? Is plus or minus 1. Okay, what is the relation between x and y? It is simply plus minus 1. Okay, now if x minus y is plus minus 1, what about y? Okay, y will become, there are two cases. Okay, if this was plus 1, y is x minus 1 or y equal to x plus 1. Okay, x minus 1, x plus 1. How simple it is. Okay, then it can be MSQ. Okay, then it can be MSQ. Okay. Paper folding one, I don't know. I have not received any such question from paper folding. Okay. Okay. So, this is what, is the, what we say, the data that is going to come out. Okay, it is clearly line. 2xy term coming, na? Yeah, 2 lines are there. Yeah, MSQ. It clearly makes a MSQ question. Okay. I think we are done. Yeah, this was machines question already discussed. Okay, guys. Gautam sir hai kya? Gautam sir idhar hai kya? Gautam sir nahi hai. Yes, guys. Okay, so we are done. I think, probably more than 40-45 questions discussed. Okay, so guys, if you are planning to gear up for the GATE 27 preparation, okay. So Om Institute now announces the GATE 27, offline, summer courses, okay, which is a short-term course, okay, which is going to, run for a duration of 60 to 65 days, daily 7 to 8 hours of the offline classes. Okay, so yeah, if you want to cover up a substantial syllabus in quick amount of time, okay, this summer short-term course is going to give you a lot of benefit. Okay, there is an early bird discount. Now for the summer short-term course, the original fee is 49,999, but you can see the discounted fee here, 44,999. That will be applicable till May 5th. And the first summer short-term course, it starts on 13th May. Okay, that depends on, your college schedule. Especially this is very much beneficial for those college aspirants. And see, even this year, let the results come. I will tell you how summer short-term students have performed. Last year, our rank 26, Pujita Siva summer short-term course, only for some, 1.5 months, to 2 months she spent here. Okay. And later she kept on, revising on her own, and also she watched our online lectures also. She got rank 26. So, if you are really college going student, and but want to cover up maximum syllabus, in the offline manner, then this course is perfect for you, because with college, you cannot be staying in Hyderabad for long. Okay, so that is why any part of country you are in, based on your college semester break, you can choose your date and you can start for the summer short-term course. Okay, if you are going to be available for the full offline course, most welcome. 26 February is the first offline course for GATE 27, both for EE and EC branches is going to begin up. Okay, all the details, okay, of the fee and all are mentioned here. Okay, also there is early bird discount. Okay, that is anyways gone, right? Yeah. So guys, that's it. That's it for this session. Okay, that's it for this session. Let's close this. Okay. Yeah, update on marathon, I'll tell you. Just now, me and Hemant sir were having a discussion. Okay, probably Monday you will have that EMTL marathon. Okay, tomorrow or Monday, mostly Monday. Okay, you will have that EMTL marathon, right? Okay, Monday you'll have the EMTL marathon. Okay, guys, bye bye. Thank you. Stay safe and take care of yourself.